Hello everyone, my name is sanobar sheikh. Our topic is zeros and poles. In this presentation, we have to discuss zeros and poles. Let's get started. First, see the definition of poles and zeros. Zeros. Zeros of a transfer function are the frequencies, values of s for which the numerator of the transfer function becomes 0. Definition of poles. Poles of a transfer function are the frequencies, values of s for which the denominator of the transfer function becomes 0. We will take the example to understand zeros and poles, and the example is given as: now we have transfer function which is h of s equals s plus 2 divided by s plus 3 into s plus 4. Let us talk about zeros and poles. For this transfer function, so we already know the zeros and the value of s for which the numerator of the transfer function becomes 0. For this transfer, poles and zero diagram is plotted on S-plane. In this poles and zeros diagram, poles are represented by cross and zeros are represented by circle. If we want to represent poles and zeros for this transfer function on poles and zeros diagram, then we will have S-plane, in which S-axis is sigma axis and y-axis is j omega, which is imaginary part of this. The circle on -2 represents the 0. S equals to 2. Similarly, we have two poles, which is -3 and -4. So we will have one cross s equals to -3 and another cross s equals -4, and this is the poles zero diagram. Now we talk about singularity. What is singularity? A point z0 is said to be singular point of analytical function f of z if that means f of z is not analytical at the point z0. Example: 1 by z minus 3, that is z equals to 3, is singular point. If a point z0 not is said to be a singular point of analytical function f of z, that means z0 is not the singularity of a function f of z. If f of z is not analytical at the point, so it really simple, the point at z equals to z0, which the function is not analytical, is known as the singularity of the function. For example, here 1 by z minus 3, that is z equals to 3, is a singular point. So let's study the types of singularity of function. There are three types of singularity function. First is isolated singularity, second is removable singularity, and third is essential singularity. So the first type of singularity is isolated singularity, and from its name it is clear that means the singularity is isolated, that means no other singularity is around it. The definition of isolated singularity: the function f is analytical at each point in the neighborhood of z0 but not at z0. For example, 1 by z minus 2 into z minus 3. So the -2, -3 are singularity of the function. Second is removable singularity. That means we can remove it. F of z at point A. So limit z to a, f of z equals to finite element, that is f of z at point is singular. So if we take limit z approaches to a, f of z, and we get finite element, that means the function is defined. Third singularity is essential singularity. So from the word essential, it is clear that singularity is essential. That means imported. That means we can't remove it. A singularity which is neither removable singularity nor pole is called. That's all we have to say about it. Thank you.